Hello, welcome to the documentary about chaos theory. I'm your host, John Johnson, and with chaos theory, you might be asking, what is it? Well, it is when events may seem random, with disorder and just wacky all over the place, but in reality, the events are able to be predicted, calculated, using mathematics. We can figure out stuff about the chaos. And to the researcher, I'm going to go to Fred Fredrickson to tell you more about the calculations.
The calculations used in chaos theory are a set of differential equations that express the rates at which all variables in the system are currently changing. The most popular system of equations is the Lorentz system, created by the founder of modern chaos theory, Edward Lorenz. An interesting example of this supposed chaos that is in reality predictable is the coin toss. It seems entirely random with that 50-50 chance, but in reality, you could flip it 10 million times and it would still land on heads, even like 45% of the time, because it can be predicted using any wind or force with which it's thrown to predict its end result.
Thank you, Fred Fredrickson, for those great data and showing how calculations work. A great example of seeing chaos theory in real life is through nature and natural things like trees, plants, weather, snow, like leaves. It's got the little pokies and like it's a leaf shape, and they're all similar shapes. Some are more rounded, some are more pokey, but they're all similar, but yet they're also complex. You look at the stems, their stems move throughout the leaves and they're all different. And another great example is snowflakes. Every snowflake is different. It's got a different design. It looks cool, every different one, but they all are like the star shape with the pointy ends, and like sometimes the circle in the middle, but they're all different and yet they're the same. And that's what chaos theory is. It's just chaos. It's just everything that seems different, but it's predicted to be the same. It's able to be calculated based off other things around it and just things around it, and they're all just similar. A final example, and this is a very easy example for astronomy, and that's what this is about. It's about astronomy and chaos theory. And the best example is the HR diagram. Before the diagram was created and thought of, there's people trying to map stars, but it was crazy because like luminosity, there's magnitude, there's heat, temp, it's everywhere. Stars are like here, and there was no good way to plot them. They were just random. It was chaos. And until the diagram came. Once it came, they were able to find that luminosity and heat, they were similar. There were stars that's similar, and then there's like the white dwarfs, the main sequence, the giant supergiants, and just astronomers were able to figure out that the chaos of all the stars and all the different data is just a simple, just similarities, because they all are similar and they're everything.